Thank you everybody for joining me in this session, and the topic for the next 60 minutes or so is baking extended events recipes without breaking a sweat. A few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant. I'm the CEO and founder at Quantum Datis. I'm a SQL Server MVP, and I've been working with SQL Server for a very long time. The first version I have worked with was version 7, so very long time ago. Currently, I'm working as a DBA at a famous Formula One team in Italy. And if you want to read my blog, you can find it at spaghettidba.com. And my handle on Twitter is @spaghettidba. Great. So the agenda for today, this is going to be really a short set of slides. First, we are going to see why trace is dead, and all the good stuff goes to extended events nowadays. And then we will see how XESmartTarget helps you extending what's already available in extended events out of the box. And well, we will go straight to the demos, which are actually recipes today, not exactly demos. Good. So first of all, trace is dead, baby. Trace is dead. So if you have been working with SQL Server for a long time, at least as long as I have, you probably remember a time where we only had trace, and it was the preferred way of monitoring events on a SQL Server. And we had tools like Profiler, super easy to use. You just had to fire it, select one of the templates, and select Start, and it started capturing events. But it had a couple of shortcomings. First of all, it was very heavy on the server being monitored, so it had performance overhead. And it couldn't capture events very deep inside SQL OS. It was limited to a set of events available at certain level. So Microsoft decided to introduce a new way of capturing events happening on the server with SQL Server 2008. Actually, it used this feature called extended events to ship another feature, which is auditing. So in SQL Server 2008, we had extended events appearing for the first time to introduce auditing. It kind of worked. It could capture some events, but it didn't have all the events available in SQL Trace until version 2012 came out. So we had to wait a couple of years to have the same set of events available in extended events. And also, the tooling was not the best at the time. The GUI in SSMS was not very easy to use. It has some bugs as well. And as I already mentioned, we didn't have all the events. So it had a kind of a rough start, but it had some merit. As we said, it was deeper inside SQL OS, so it was capable of capturing events that are not available with SQL Trace, and also has a lower performance overhead compared to SQL Trace. Good, so moving on, some years have passed, and it's 2021, and we still have extended events. We still have SQL Trace as well, and it still works. It is deprecated. I don't see it going away anytime soon. I think it's here to stay. But you have to keep in mind that all the new events are not coming to SQL Trace anymore. And for the new features of SQL Server, you get new events added only to extended events. They're not going to SQL Trace. And especially if you're working with the Azure flavors of SQL Server, so Azure SQL Database and Azure Managed Instance, the only way to monitor those is by using extended events. You don't have trace there because you don't have access to the file system, which is what was baking SQL Trace. So no access to file system means no SQL Trace. Also, some years have passed and the tooling has improved quite a lot. If you're looking at SSMS, the GUI has now improved in terms of stability and usability. And also we got some nice additions like the extended events profiler. Good, so we are trying to look at extended events in this session from a different perspective. We're not going to go through how to set up a session, how to capture individual events. We are going to focus on what you do with the events you capture. And once you have a session set up with the set of events you want to capture, the next thing you have to do is decide what to do with all these events that get captured by the session. And the way to process events is by using targets. You probably know the first two targets that you see here coming straight from the documentation. So you have the ring buffer target and the event file target. This one, the ring buffer target, is capable of saving events to an in-memory structure with first in, first out structure. So the newer events push out older events from the queue. And then you have an event file target that is capable of writing events to a file on the file system. And then we have some other types of events, targets, like the event pairing target, which is capable of pairing events of that usually come in pairs, like a lock acquired, lock released, and so on. And then you have some more specialized things like the event tracing for Windows, or two counter targets like event counter and histogram target. These two targets are capable of counting events. The first one, the event counter, simply counts events, and the histogram target groups events before counting. And so this is all you can do out of the box with events. This is all the processing capabilities that you have using the built-in targets. So if you're looking at this list, you probably are thinking that we are missing a couple of things, like we don't have the ability to write to a database table. We don't have the ability to send emails in response to events. So there are many things we cannot do with extended events out of the box. So this is why I created XESmartTarget. XESmartTarget is an open source project that you can find on GitHub. So this is the address if you want to go and have a look. And what it does, basically, it uses the streaming API for extended events to attach to an existing session and do stuff with the events captured by the session. And basically what it does is it extends the capabilities of the built-in targets to automate and do more stuff, more actions with the events you are capturing. You don't have to write any code to use XESmartTarget. All you have to do is fill in some information in JSON files, and you just feed these configuration files to XESmartTarget, which is a command line application, which reads the configuration that you passed in the JSON file, and then XESmartTarget is capable of reading the JSON file, understanding what you want it to do, and execute all the actions configured in the configuration file. The way it does so is by using some response types for performing specific actions. Let's go quickly through these response types. The first one is a CSV append response. As the name suggests, it is capable of receiving events from the stream and writing them to a CSV file on disk. And then we have the table appended response. This is the main reason why I created XESmartTarget, because I wanted to write extended events data to a database table, and there was no way to do that using the built-in targets. Then we have the group table appended response. This one, before writing the events to the database, groups them first in memory and then on the target table. And if you have some existing data, it merges the data with matching keys. Then we have a replay response, which is capable of replaying execution related events like RPC completed or SQL batch completed. And then we have an email response that can send emails in response to particular interesting events like capturing deadlocks or blocking. We also have an execute T-SQL response that executes SQL commands in response to events. And then we have two response types capable of interacting with NoSQL databases. The first one is InfluxDB using Telegraph, which is the collection agent for InfluxDB. And the second one is Gulf TCP response, which is capable of writing to a Graylog database, a specialized database for collecting and analyzing logs. If you go to the documentation page, you can see that all the different response types expose different attributes that you can set in the JSON file. So here, for example, for the table appended response, we have the server name, the database name, table name, username, and password. So these are all the properties that you can set on the target in order to configure it and make it perform the actions that you want it to do. Good. So when in doubt, you can go to the documentation and you always have an example of how to use the different actions, the different responses. Good. So, well, this is all the slides I have for today because the rest is all demos. So let's go ahead and run some demos. First of all, we are going to use a notebook for this. We are using Data Studio, and we have a notebook here where we have some description of what we are doing. This is all available for download from my GitHub, so you can go and play along with me. All you will have to do is configure these two variables, so the name of the server and the path to this notebook itself. This is a notebook that runs PowerShell. It's using the PowerShell kernel. So it is a bit different from running PowerShell scripts directly from the console, but it runs these commands in a PowerShell environment. So before you can use this, you have to set which server is your target and which is the path to the notebook itself. Okay, so let's go ahead and run the first recipe. We are going to capture all execution-related events and write them to a CSV file. Why do we want to do that? Well, all we are trying to do here is mimic what we can do with a profiler standard template. This is super easy to do when you're using Profiler. You just have to start it and select the template you want to run, and it captures all the execution-related events. But I will show you that it's super easy, even with extended events, to do that. And we are writing to a CSV file instead of writing to an XCL file, because we don't want to use the storage of the server. So writing to a CSV file uses the storage of the client instead. First of all, we are going to need a session for that. And if we wanted to use the profiler standard session, the easiest way to do that is by using PowerShell and DBA tools in particular. There's a functionality coded by Christy Lemaire in DBA tools that contains many templates for interesting extended event sessions. So you have templates for doing a lot of stuff. And if I run this get DBA XC session template and pipe that to a grid view, you can see that we have many templates here for doing many actions, many sessions on servers. And we also have profiler equivalents. So one of these is the profiler standard, and we are going to use that. So first of all, we are going to run this command, import DBA XC session template. We're going to call the session recipe 01, and the template we need is the profiler standard, and we are also going to start it. First of all, I need to invoke this because I don't remember whether I did it or not, so I'm going to run it again to reset my environment and set the variables I need. Okay, so let's create a session called recipe 01. We can have a look here, and if we go to management extended events sessions, we can see that we have a recipe 01 session that has been created by that command. So that's cool. Let's go back to the notebook, and now we are going to use XESmartTarget to capture and process the events. And the way to do this is by configuring XESmartTarget with a JSON file. Let's have a look at this file. Okay, so every JSON file to configure XESmartTarget contains a target definition, and this one contains a first section that configures the response itself. So how to connect to the server, so the name of the server where the session is hosted, then the session name to connect to, and some other properties like fail on processing error. And okay, sorry. And then we have a configuration of the response itself. So we can have here an array of responses, and here we are with the first one. We only have one in this array, and this is of the type CSV appended response. In the documentation, you will find that these are the properties that you can work with. So we are going to use the output file to specify where to write the CSV file, overwrite the file, and here we can specify the columns that we want in the output file. These columns are names of actions or fields in the session itself. And here we can filter which events are going to the output file. So in this case, RPC completed and SQL batch completed. If you remember what you have in the profiler standard, you also have other events that we are not interested in. So these are the ones we want to process. Good, so let's go ahead and run XESmartTarget using that JSON file. All you have to do is run XESmartTarget, and one of the arguments is -- file and the path to the JSON file. There's an optional argument, which is the path to the log file. So let's go ahead and do it. As I said, this is a command line application, so no GUI here. It is running in a console window. And now it says I'm connected to the server and I'm waiting for events. So let's see what it's doing. At some point, it will capture some events and write them to a file. Let's have a look at the file. Oh, here we have some data. It has been captured right now. So this is the time we have now. This is the header of the CSV file, so the name of the columns. And here, code has this rainbow CSV feature that helps you identify the columns. And as you can see, we got the name of the event, the date, and this is the application name, server principal name, and then these are the statements. So you can go and scroll down to see all the events coming to this CSV file. And if you go to the end, you can see new events flow into the file in real time, because code is smart enough to refresh your file while the capture is running. So that's pretty cool. Okay, we can stop this, and we can stop XESmartTarget. You can stop it by Control-C, pressing Control-C, or closing the window. And we can now move to the second recipe. In this case, instead of writing to a CSV file, we are going to write to a database table. As I said, this is the reason number one why I wanted to create XESmartTarget, because I wanted to write data to a database table. And there's no way to do that out of the box with extended events. So first of all, we are going to need a session. In this case, instead of using DBA tools, I'm going to use a T-SQL script to create my session. And in this case, I'm capturing, again, RPC completed and SQL batch completed events. So we're capturing the same kind of information as before. Let's start the session, recipe 02, and now we are going to use a table appended response. Let's have a look at the JSON file for it. Okay, again, we have to configure which server to connect to, which session to connect to, and then we have the response. This time it's of the type table or appended response, and we have to configure where to write the data. So the name of the server, name of the database, name of the table, and we can specify whether to auto-create the table or not. If we let XESmartTarget create the target table, it will use the .NET types to create the columns. So if it's a string, it's going to create NVATA max column. So it's not recommended, actually. So you better create your tables up front if you have a lot of strings and you want to do some processing with the data. Again, you can specify the name of the columns you want in the output, and these columns are fields or actions from the events. And this is going to use the names to map fields and actions to the names of the existing columns in the table. And again, you can filter which events you want to capture and process and with this response. let's go ahead and do this. I'm going to start XESmartTarget, and now, as you can see, I hope this is big enough. I'm going to zoom in a bit. It says I'm writing to the target table 291 rows written and more rows written. So it is actually writing to the target table. Let's see if this is true or am I cheating. Let's have a look at the data. I'm going to use this SMS to query the target table. And as you can see, we have some data flow into this table. So we have RPC completed with its statement column. We also have some SQL batch completed events. Let's try to find one. Oh, do we have any of those? RPC completed and SQL batch completed. Oh, here are some. So SQL batch completed, as you can see, doesn't have the statement column. It has the batch text. So it would be great if I could do as I do with this SMS. If I go here, I can go to my recipe 02 session, and I can do watch live data, and I can create columns like this one that have events from both events in the same calculated columns. So I want to do something like that with XESmartTarget. Let's see how you can do it. This is the example for the next recipe, recipe 03. In this case, I'm going to manipulate the output in order to merge the two columns. I will clone the previous session, so recipe 02. I'm going to clone it and call it recipe 03 this time. Again, I'm going to use DBA tools for that. Super easy to clone a session. And now we will use again the table appended response, but it will be configured in a different way. So again, we're connecting to this server. We are connecting to session recipe 03, but this time we have two responses. So the first one filters only the events for RPC completed, and the second one only gets SQL batch completed events. And now we have all the columns that we had before, but we have calculated columns, a calculated column which is called SQL, and it contains the statement field. And also we have total IO, which is defined as logical reads plus writes. And the same goes for the other response. So combining the two, we can write to the same column. I'm going to start XESmartTarget now. Now it is running, it is capturing events and writing to, you see you have two sets of data now for the two different events. Let's have a look at the data that we have here. I'm going to go ahead and query the recipe 03 queries. And now we have this SQL column and total IO. This is calculated. Let's see if we get some SQL batch completed event. Oh, here are a couple of those. And as you can see, the SQL column contains for both events the text of the command. So that's pretty cool. I'm going to stop this. Now I'm moving on to the next recipe. Now, this is something that all DBAs have done in many different ways throughout the years. Once you capture blocking and deadlocking, you want to raise some alerts and send an email with the details. We've been doing this with many technologies, many techniques in the past. You can do that with XESmartTarget as well. So first of all, we need a session for that. And the session looks like this. It captures the blocked process report and the XML deadlock report events. But before we get these blocked process report events, we need to configure the blocked process threshold configuration option on SQL Server. And I'm going to set it at 10 seconds. If we don't set this one, the events don't fire. Okay, so I'm going to start the session, which also configures the threshold for raising the blocked process report events. And now I am going to send emails using XESmartTarget and the email response. I am also going to use PaperCut, which is a nifty tool for running a mail server, so an SMTP server and an SMTP client, all collapsed in a single application in order to display these emails. It is not starting. PaperCut, okay. Okay, this is what it looks like. Basically, it looks like an email client, but actually it also has an SMTP server functionality. So this is good for troubleshooting and for demos. And I'm going to leave this running here. And now we need to configure XESmartTarget in order to fire alerts via email. We need a JSON file for that. And it looks like this. Always the same, connecting to this session. And now we have one response to write the events to a table. Nothing to see here. We've seen this already. But what we also have here is a third response type. And this is an email response. And we can configure which SMTP server to use. In this case, it's localhost. The server is demo at localhost, and it's going to send an email to the DBAs using the subject let the local quote. And this is the body. And interesting, we can also attach one of the fields or actions using the attachment property. In this case, I'm going to take the XML report property, which is actually the XML, save it as a file, and attach it to the email I'm getting, giving it the name deadlock.xdl. And I'm filtering only for the XML deadlock report events. So let's try to run that. Fingers crossed. I should be able to capture those. Now we only need to generate some deadlocks. Normally you would have to wait for a couple of minutes in production to get some deadlocks, but I'm going to have to generate some deadlocks artificially in this case. So let's see if we get some deadlocks notifications here. We just need to wait for, oh, some notifications are flowing in, so good. We just need to, okay, enough deadlocks. Thank you. Let's have a look. What we did get. So we got these emails. The message body is what we said. This is a subject we configured. Let's have a look at the sections of this email. We also have a deadlock.xdl attachment, so we can go ahead and open it. And this is the XML of the deadlock report. We can also save it. We can save it as ctemp deadlock.xdl, and we can open it in SSMS. So ctemp deadlock.xdl, and we got a nice deadlock graph here that we can go ahead and analyze to see what was happening. That's quite an interesting one now that I look at it. Okay, no time to look at that now. I hope this was clear enough. Let's go ahead and have a look at more recipes. Other things that may be happening, imagine that you have somebody that runs, somebody or some application that runs some transactions, and instead of closing the transactions, they leave them open and step out for lunch, or leave a message box that somebody has to click to roll back when an error occurred. So these are things that you don't really want to have happening on your database, because it would block everybody. So what you want to do generally is kill those dangling transactions. In this case, I am going to use XESmartTarget for that. So first of all, we are going to need a session for that. We're using, again, the block process report event, and we still need to configure the threshold for this to run. I'm going to close this one. We don't need it anymore. And I'm going to start this session. And now we are using the execute T-SQL response. So once we get a notification that this command has been blocked by more than 10 seconds, we will run a command that takes care of killing blocking sessions with open transactions and sleeping. So we need a JSON file for that, and it looks like this, super simple. Server name and session name connects to recipe 05. We are using the execute T-SQL response. This time it has to run the command against this server, this database, and this is the command it will run. Exec kill blocker, and here we have curly braces with the name of property coming from the events. So this is either a field or an action. And we are filtering this for the block process report events, and filter only the ones that have a duration greater than 20 seconds. Okay, let's go ahead and do it. We are starting XESmartTarget. It's running here, and now we can run the command that was specified in XESmartTarget. This is a procedure that will get run. It will pass the transaction ID, and this will be used to retrieve the session ID of the blocking session. And no, this is the blocked session, sorry. So it will look for the blocking speed joining many DMVs, and this speed will be used to kill the offending speed, the blocking speed. Okay, so let's try to do that. I'm going to use two commands here. First of all, I'm going to open a transaction and update one row on the AdventureWorks database here. And the transaction here is open. So if I try to query that table here, I'm stuck. This is waiting for the other session to finish, to commit or roll back the transaction. And as you can see, time here is passing and I'm still blocked. So when I reach 10 seconds, the first event will be raised, and the second will be raised at 20 seconds, and then this has finished because this one has been killed by XESmartTarget. Why? Because we configured it to be killed after waiting for 20 seconds. And if I try to run this select, I will see that this connection has been killed. And in fact, it says, oh, nope, this has been killed. So if I run this again, I will reconnect, but the connection was killed. Good, all went as expected. Great, so let's go ahead and run another recipe. This one, we will audit all the logins. So imagine that you get, you inherit a server with many databases, many logins, and you don't want to keep all those logins. You only want to keep the ones that are active on the server. You would have to monitor login events over time to see who is connected to the instance. And there are many ways to gather this information. You could actually write successful login events to the error log, but this makes the error log huge very quickly. You could also capture these in an audit file, but this as well gets very big. We're not really interested in the individual logging events. All we want to know is who has logged into the server in the last days. So we may be okay with a single line in a database that says this login has showed up these many times, and this is the first time it appeared, and this is the last time it appeared. We don't need all the individual events. So what we are doing is we are grouping all the events before writing them, and we have a response for that, which is the group table appender response. So what we are doing is we are capturing login events using this session definition. So we're capturing the SQL Server.login event. And we're gonna start this one. And now we configure XESmartTarget to group these login events in memory and then in the database in order to have a single summary row for each login. Okay, let's see how we do it. All the usual configuration, and then we have group table appender response. So it has to write to a database same as a table appender response, but the magic happens in the output columns. So we will have some columns that are not summarized, and these are the keys to the target table, and some columns are summarized instead. We have this minimum collection time, maximum collection time. So this will be the first time the login has been captured, so first seen, and max collection time will be called last seen. And then we'll have the count of all the events. It will be the logon count. Good, so what will XESmartTarget do? It will use these three keys to group the events, and then it will summarize using these aggregates and write to the target table, merging any existing rows with the same key. Let's see how this works. We're going to start XESmartTarget. And at some point, it will start writing data to the database. Okay, so it says one row aggregated, one row written. Let's see how that goes. Okay, again, one row. So I'm gonna run a couple of commands in order to generate more events. Okay, 5 rows. Let's have a look at the data it is collecting. So as we said, the first 3 columns are the keys. So it will have for every combination of these values a single row, and then it has a first seen, last seen, and log on count. Gonna have to mute. Okay. And what else? If we keep running this, you see that the numbers are going up. So it is summarizing and merging new rows captured by the events by merging the numbers here. So you see these are going up. Okay, this was 14, now it is 16. Okay, so it works. If we keep this running for a while, we can have a complete picture of who is using this instance. So we solved our problem. We can use the same technique to identify unused objects. I'm going to go through this very quickly. In this case, a session is using a different event. The event is lock acquired. So it will interpret different lock modes as reads or writes. So the reads are schema stability and intent shared and shared locks, and all the other ones, so intent exclusive and exclusive, are the write events. So we can use this session to capture all the locks on the server, and we can use XESmartTarget to all these events and write them using a group table or appended response for the lock acquired events. The ones with the mode X and IX, sorry, not X and IX, are the reads. So we can write them using a client application name, database ID, and object ID key. And then we can calculate the last read and the number of reads using these two aggregates. And if we filter for mode X and IX, these are the writes. So using the same key, we have the maximum collection time. This is a last write, and max collection time, sorry, count collection time. Now this is the number of counts. So if we run this, now it will start writing to the target table. Let's have a look. If we keep running this for a while, you can see that we have some rows that only have reads and others that also have writes, and some others only have writes. If we keep refreshing this, we see the stats are updating. So if we keep this running for a while, we will have a complete picture of what is writing to each object in the database and which are the most active tables in the database. And we will also see which ones are not used if we compare this list with what we have in the database. So if we have some zombie objects, we can kill them, we can delete them. Good, so let's stop a few XESmartTarget windows. And now we can move to the next recipe. This is a workload analysis. So the idea for this recipe came from a blog post by Brent Ozar, and basically he wanted to find out who was using the most CPU. So which user was consuming more CPU. He used the resource governor to detect that. But instead, we will use XESmartTarget. Again, we will have to set up a session for this. This is going to be RPC completed and SQL batch completed events. Again, we use these a lot in these demos. And we're going to start this session. And again, we're going to use a group table appended response. So we're doing something particular here. Let's have a look at the JSON. We are using the group table appended response. So we have a calculated column here, which is defined as the substring of the first 16 characters of the snapshot of the collection time, sorry. So this is the collection time as a string. The first 16 characters are up to the minute. So actually, the snapshot ID is the date without seconds. And then we use client application name, server principal name, database name as the keys. And then we are grouping on these, and we are summarizing these other columns. So CPU, duration, logical reads and writes, and the count of collection time is the number of executions. So let's try to do that. I'm going to start XESmartTarget. Now, this will summarize what is happening on my server. So it will group all the events by minute and all the keys that I specified. And it will calculate and aggregate, calculating all the metrics that I wanted to have in my database. So it is writing data. Let's have a look at the data. It is writing. So this is the raw data, and for this snapshot ID, so 431, it is capturing data for the client application name, server principal name, and database name, and this is the CPU it is consuming, and other connections are consuming a different amount of CPU. So now we change the minute. Now you can see that we have a new set of rows for this other minute. And if we keep updating this, we will have more and more rows flowing here. And if we change the query a bit, we can see this is summarized. So we can see the group by server principal name, for instance. It shows who is using all the CPU. And this is nice to visualize in a Grafana dashboard. So I'm going to go ahead and visualize it. And okay, this is what we have. So if we see this in a chart, this is the analysis by login, and we can see clearly that the DS2 user is the top consumer of CPU, and all the other ones are just consuming a very low amount of CPU. And we can also do the same analysis by looking at the application instead of login. So you can see that the .NET SQL client data provider is the top consumer. So leaving this running for a while will give you an idea of who is consuming your CPU. Okay, I'm going to stop it. And this is the last demo for today, promised. The bonus one, we are using Grafana, a Grafana dashboard to visualize some data that we are pushing to an InfluxDB database using XESmartTarget. So what are we doing? We are setting up a session for this that captures log process report, error reported, and RPC completed events, and also the SQL batch completed events with result equals to. So the errors, these are typically timeouts. And then we also get the XML deadlog report. So I'm going to go and start this session. And we want all these events pushed to an InfluxDB database. We're going to use a special JSON configuration for XESmartTarget. And this will use a telegraph appended response. We have to specify the name of the measurement we want to write to. A measurement in InfluxDB is a kind of similar to a table in a relational database. And we need to specify the tags. These are same as a column in a relational database. So a tag is an indexed column, and a field is a non-indexed column. So we have to specify which fields and actions go to tags and fields in the target measurement. And we do that for different events. So for error reported, I'm writing to this measurement. For timeouts, I'm taking the SQL batch completed and distributing my tags and fields this way. Okay, so I'm not going to show you the details for this. It doesn't really make sense, but what I want to show you is that if I run this, I'm not running XESmartTarget directly. I'm running Telegraph, which in turn is listening for events from XESmartTarget. So it's a double pipeline here. And all I have to do, I need to generate some deadlocks. And if I leave this running for a while, I should be able to see some deadlocks in my dashboard. I'm going to use the actual monitoring platform that we use for this. And we can see that we have some timeouts here, and all these events have been pushed to the InfluxDB database by Telegraph using XESmartTarget. If we keep refreshing here, we should also see some deadlocks. Oh, I'm looking at the wrong one, sorry. This is a good database, the right one, the correct one. Okay, so we have some events here, we have some deadlocks, and as we showed before, these are the deadlocks, and the data has been written to the InfluxDB database. This is the XML report for the deadlock. Good, so I'm gonna go ahead and stop this one because we are finished. Let's go back very quickly to the slides. We don't have any. Okay, so if you have questions, I'm happy to take them. Otherwise, thank you very much for attending, and you can always shoot me an email. Can XESmartTarget tool used on Azure SQL? No, because Azure SQL database doesn't have the streaming API, but the managed instance does. So you can use it on a managed instance.